Well, when you think about all the sort of resources that we talk about as essential for societies, the one that often gets left off the list is fertile soil. And yet it's the most fundamental resource that we have. Most of our food comes directly or indirectly from the soil, and the way that we care for the soil will, in the end, determine how the earth is able to care for us over the long run. It's the fundamental resource we talk about far less than we really need to. So if you look back through the history of civilizations, as I did in my book, Dirt, the Erosion of Civilizations, and you explore the role of soil erosion in the course, fate, and longevity of human societies, it's pretty hard to avoid the conclusion that the loss of fertile topsoil off of whole regions, which has happened in the past, played a role, and arguably a major role, in limiting the longevity of civilizations. Now, there were often other triggers that helped sort of take out societies, climate changes, droughts in classical Egypt, for example, problems with neighbors, wars, politics, social evolution, all the stuff you really find in history textbooks. But it's my opinion that what sets the sort of the long wavelength periodicity that underlies the rise and fall of civilizations, the things that makes them resilient or vulnerable to perturbations that can take them out, is the health of the land. Well, when you look at the problem of sustaining agriculture over the long run, there's really two problems that we have to solve simultaneously. And one is the problem of stopping the erosion of soil, preserving it as the physical body that we need to cover the rocks up and grow food in. And the other is preserving and maintaining the fertility of the soil. And different solutions that people offer to different problems can actually address one problem, not the other, and we need to solve them both simultaneously. So if you look at organic agriculture, for example, well, organic agriculture is what did in Rome. They were organic, they were well before the kind of methods that we have today, but they literally plowed their topsoil off their homeland. So the problem isn't as simple as organic versus conventional agriculture, but we need to basically develop a new style of agriculture that not only preserves the physical topsoil itself, but also preserves its fertility. And the sort of the modern agrochemical agriculture that we have has, in many ways, substituted sort of additions that we have, added fertilizers, herbicides, pesticides, for the native fertility of soils. And I think we're going to have to, over the next century, relearn how to dial back those inputs, while simultaneously shutting down soil erosion as a major problem. And that's going to require sort of merging things like no-till agriculture and organic or organic-ish low-input agriculture. I think we have a challenge to sort of relearn how to do that on a broad scale while restoring life to the soil to help with the cycling of nutrients and the production of phytochemicals that are actually important for our own health. Well, if you look at the long-term security of the food supply, the best thing you could do to secure it is to regenerate a regenerative agriculture, an agriculture that would regenerate the fertility of the soil even as we actually use it to produce food. And many of our methods today sort of don't work in that direction. But there's a lot of farmers that are actually starting to change and to adopt practices that can help cut down on soil erosion and can actually help reduce the reliance on agrochemicals that can have harmful effects on soil biota and soil life and thereby native soil fertility. So if we look at food security sort of in the coming world, the post-oil world, the kind of world that, if you think about geologic time the way a geologist does, it's just tomorrow morning in the future of our civilization, but yet it's a long time in terms of policies. We've got some time to try and retool our policies and methods to try and align our agricultural production with a more regenerative approach. So if we don't pay attention to this, it's going to become a huge problem. But we've got some time to figure it out, and there's a lot of movement that's moving towards creative solutions to these problems, even though we still have a lot to learn about how to really pull some of them off. If you look at the question of urban agriculture and how it might actually help in a transition to a long-term sustainable agriculture, there's a couple things we need to consider. One, I think there's good examples of cities in the past and even in the present where a large proportion of their vegetable production has been brought into the city. But if you look at the problem of producing sort of grains, meat, and dairy over the long run, it's kind of hard to imagine moving those in a big way into an urban environment. So I think what we really need to think of is in terms of food systems over the long run and trying to integrate urban and rural economies and environments in areas where nutrients can flow essentially both ways. on either the front end or on the back end, because we need to if you really want to generate a long-term regenerative agriculture, we're going to have to rethink what happens to our organic wastes in cities and getting some of that material back to the land to regenerate nutrients that we've taken off the land. It's going to take a while to figure all these things out, and the role of urban farming probably has a role to play. But if you look at something like hydroponics, for example, well, plants grown outside of soils still need all the nutrients they normally get from soils. So the first questions you run into are, where are you going to get those nutrients? Is it energy efficient to do so? I mean, the beautiful thing about naturally fertile, life-filled, microbe-rich soil is that you've got literally trillions of tiny partners working for you for free, as long as you feed them the right stuff. And often what they want is what we consider waste. If you look at the problem of global hunger today, there's what, 1 billion or so people that go hungry on a regular basis in the world. And that's a humanitarian tragedy, and it's a social tragedy in the sense that we already grow enough food on this planet to feed everybody. The global hunger problem at the moment is one of distribution and economics and equity. It's not so much a one of simple production. Now, if the human population continues to rise, as it's projected to do so at least through this century, then will this become a bigger problem? And part of that depends on what we do, how we treat our land. And clearly, if we continue to degrade farmland at the pace that it has over the last century, when we've lost something like 1/3 of global cropland to crop production since the Second World War, and if we do that again, it's not going to be good. It's going to be pretty ugly. On the other hand, if we transition our agriculture to actually regenerate and restore farmland, there's a lot of degraded farmland around the world that could be brought back into agricultural production. And so I think in terms of sort of food security, we need to separate the equity issues from the simple production issues. And over the long run, we need to take much better care of our farmland in the context of its ability to continuously generate crops, not to do it over the short run. And in terms of the human population, I mean, that's obviously a very complicated and controversial issue. The good news is it looks like, I think it's projected that the population globally is going to plateau out this century. The challenge will be making sure that we can actually feed everybody when we hit that target. I mean, if we just look at the soil erosion problem globally, depending on where you look, you'll sort of come to different conclusions. There was a review done back in the 90s that looked at sort of the rate of topsoil loss, that the numbers they came up with were kind of scary in terms of the long-term projections. But one thing that's happened since then is a lot of even fairly large farmers around through the U.S. Have been converting to no-till agriculture. The long-term soil loss problem is in many respects a problem of using the plow, over-reliance on the plow. And why does that happen? Well, think about what a plow does to the surface of the earth. It turns the soil over. It leaves bare earth vulnerable to wind and rain, and that's how erosion races ahead of the rate of soil production. You let that go on long enough, and that's what the Romans did. It's what we did in the southeast colonies of the original United States. And that causes societal problems over the long term. But the adoption of no-till agriculture on fairly large acreages in the U.S., it's still the minority of cropland, but it's been growing and growing fairly rapidly. For example, I had the photograph on the cover of Dirt, the Erosion of Civilizations, the book where I describe a lot of this stuff. It shows some farm machinery from the Dust Bowl in South Dakota. Well, I just a few weeks ago visited some very progressive and innovative farmers in that area in South Dakota who've had an amazing influence over the last 20 years, where we did a several hundred-mile circuit of the area. There's very few plowed fields anymore. Why did these guys mostly go to no-till agriculture? Well, it turns out that they can save money and maintain their crop yields because they drive less across their fields. They're using fewer agrochemical inputs because they've gone to cover cropping and crop rotations along with no-till. So they're still using some herbicides, but not many because they don't have many weeds. So they've gotten savvy about doing what we could call agroecology or ecologically based agriculture. Well, these are large commercial farmers, and they're actually doing very well economically because they've cut their costs by relying less on agrochemical inputs and less on petroleum, and they've maintained their yields. So they're getting the same return with less expense. That's a good business model. And so I have some optimism for the sort of spread of those kind of techniques because it's starting to make sense. For one of the few points in history, it's starting to make sense where the incentives for farmers over the short term are starting to line up with societal's needs over the long run in terms of maintaining the productivity of the soil, its fertility, and its presence on the landscape. What's going to be a challenge, I think, over the next century is to figure out sort of what's the mix of organic practices, organic-ish practices, and other more conventional practices that could be used or dialed in to try and maintain productivity. And realistically, it's likely to vary with different soils and different environments and different climates, with different crops and different economies. There's a lot of variables that go into it. But there's some good changes that are going on. Now, I could put my pessimist hat on and give you sort of a different answer, but I prefer to look at the world optimistically because I think we actually really do have a chance to solve these problems. Yeah, so how does no-till agriculture work on a large scale? There's a couple ways. Essentially, the key thing is leaving the crop stubble from the previous crop on the land as cover, that acts as a cover, as mulch. And so you plant through it. And there's different implements that are actually made for that. John Deere makes implements to do that. I mean, there's sort of large commercial applications for that. And you can either sort of cut a row, just a narrow strip down in which you plant seeds, so you leave most of the soil intact. Seeds can be drilled or punched into the soil. There's different ways to do it, but the key thing is to essentially have minimal disturbance of the ground surface. And if you couple that with the growth and retention of cover crops, things like planting legumes to bring nitrogen back into the soil, to return nitrogen to the soil, or to simply cover the surface when there's not much of the crop, the commercial crop, or if you alternate what's grown in the same fields, or rotate crops in ways that are unpredictable to the pests and pathogens. You can break the cycle of pest and pathogen infestation by simply making it unpredictable for them. If you grow the same thing on the same field year after year, you can just go corn, soy, corn, soy, corn, soy. Well, the crop pests figure that out, and they'll know, oh, 2 years from now, there'll be corn back in the same field, so some of the corn pathogens or pests will lay dormant for a year. Why? Well, because they have some genetic variability. And so if we select for the ones that are every other year, well, you do that experiment long enough, and sooner or later, most of them are coming back every year. They adapt really fast. It's one of the problems with pathogens, and so we have to kind of be more clever. So that combination of keeping material covering the surface, growing with cover crops in association with crops, and rotating our crops intelligently. Those things can greatly transform the way that we grow food with not much of a hit on yield for a huge decrease in the agrochemical inputs. Yeah, no, there's some fairly large producers have been adopting techniques like this, and it's realistically, it's probably easier to do regenerative organic agriculture on smaller farms, but there really isn't a reason why we can't do a lot better on really big farms. Yeah, and if it turns out that farmers can actually do it profitably, more of them will adopt it more rapidly. And I think that we may be, as in a world where it's projected that the price of oil and fossil fuels is going to go up this century. You can pick your time frame, and everyone's prediction is going to be wrong. Something's going to happen, but no one's probably going to name. Well, somebody will predict it just right, but who knows who that'll be at this point. But the key trend of sort of rising cost for maintaining what we now call conventional practices is at some point going to intersect with the curve of, oh, it actually makes more short-term economic sense for farmers to do things a little more innovatively, a little different ways that I think will stand the test of time a little better. Yeah, when you look at the long-term questions of how we could actually encourage sort of the adoption of more sustainable farming practices, we really sort of need to look at how our regulatory incentives and subsidies line up in agriculture. And for a lot of the time in the recent past, we've basically been subsidizing practices that destroy the long-term fertility of the soil, whether that's through the ways that the crop insurance programs are set up or the commodity prices. And we ought to be thinking about what is the best way to incentivize farmers for doing things and to compensate them for doing things that are in everybody's long-term best interest so that those things become in their short-term best interest. Yeah, if you really look at soil as the strategic resource that it is, its value plays out over generations. In the past, one of the things I go into in the dirt book is how previous societies have often mined soil to generate wealth today. The fundamental challenge of sustainable agriculture is how we can actually use the soil to generate wealth and food for us while maintaining its ability to do so into the future. And in that sense, we really ought to be viewing soil as an intergenerational trust. And so that farmers who may own their land are still holding that resource in trust for future generations, and all of society should be willing to compensate farmers who are doing a good job of maintaining that trust, because it's everybody's great-grandkids who have a stake in the outcome. So if you look at the connections between soil health and human health, there was some authors in the 20th century, Sir Albert Howard, Lady Eve Balfour, some of the pioneers of organic agriculture, that argued for fundamental connections between the health of the soil, its ability to generate healthy crops, and that's ability to sustain healthy populations, to sustain health in human populations. And when they were writing, a lot of the mechanisms where you might connect those were really cryptic. They weren't sure essentially how they worked. They were just convinced there were connections. Some of the things that have been discovered over the last couple decades about the relationship of microbial life to the health of plants and to the health of people are things that we go into in the Hidden Half of Nature book. Many of those things, I think, we still have a lot to learn about, but the connections between the way that the microbial life in soils can scavenge nutrients, can essentially collect phosphorus out of rocks and bring it to plants and trade it to plants in exchange for exudates, sugars, carbohydrates that plants leak out their roots. There's partnerships that have formed in the soils that essentially result in a barter system in the rhizosphere, the microbe-rich zone around the roots of a plant. The exchanges that go on in that arena enhance the health of the plants by bringing in nutrients and especially micronutrients, sort of mineral elements from the soils. And if we grow plants in a medium that don't have sort of a full complement of soil microbial life that's providing that service, then you would imagine that the mineral density, the nutrient density of the crops would actually go down. We've seen great decreases in mineral density in crops, nutrient density over the last half century. The cause of that is controversial, and how much of that may actually be due to changes in microbial life, frankly, is something that still needs to be looked into and studied and evaluated. But the mechanisms where you might posit that connection that play into the health values in the crops that we then eat and what that does to us are I think, important and need to be looked at. And so those kind of connections are no longer sort of in the realm of, well, how does this work? This couldn't be possible. And they're now in the realm of, wow, what are the microbially mediated pathways that are actually doing that? And how much of that is that, how parallel is that to some of the microbial, the human microbiome processes that are actually, we now know are happening in our own gut, that are kind of the inverse of the relationship between microbial life in the soil and plant roots and what's happening in our gut. And again, we go into that in the Hidden Half of Nature in terms of the fundamental parallels between those worlds. But the reality is that the microbiome scientists in both the plant and the human world are just cracking open this new view of the way that nature actually works at a microbial level. And the message that's really coming out fairly loud and clear is that those processes that are sort of invisible to us in our everyday lives actually matter in terms of the health and the function of nature at the scale that we run into and know in our everyday lives. It's sort of a whole new view of nature and ourselves. Boy, well, at a strategic level, what governments could do to help protect soil over the long run is to encourage and when necessary, subsidize farming practices that are regenerative, that actually rebuild soil. The Conservation Reserve Program, for example, that the Natural Resource Conservation Service has run, has been a good program. Every now and then it gets stripped back or gutted. And, if we thought about our agricultural subsidies as long-term investments in the health of the land, we would probably restructure them in some ways. We would help facilitate the transition off of the plow. We would have a lot more research going into how to develop organic and organic-ish methods of large-scale agricultural production. We would be developing ways that could actually be shared that are non-proprietary between farmers of better ways to do things. There's a lot that could be done in terms of methods. What's the right crop rotations to actually use to try and minimize the use of herbicides? Probably varies by climate, by geology, by soil type, by climate, and by crop. There's a lot of work that could be done on that. So if you look at societal investments, investing in research that actually could be translated directly and freely to farmers to improve their profitability and bottom line in producing things better from everybody's perspective, those would be good investments. Boy, the single biggest thing that you could do to essentially restore life to your soil is to add organic matter to it. It is the lifeblood of the soil. And that applies whether you're on a big farm or in your backyard garden. Growing some food at home is a great way to actually reduce one's footprint, but also as an excuse, as if one needs an excuse to essentially rebuild and restore the soil. One of the awkward things about trying to vote with your consumer dollars with sort of soil rebuilding practices today is that simply buying organic doesn't guarantee that those farms are building soil. Now, many organic farms are, but there are also large organic farms that are plow-based, which may be degrading the soil over the long run, even as they're doing good practices in terms of organic practices in the short run. At the same time, there's some farms that are actually using some agrochemicals but are rebuilding soil life and are really regenerating the native fertility, but maybe using some fertilizer, for example. Because if you're going to be sequestering carbon in the soil, you need nitrogen to bond with the carbon to actually build the soil organisms that will sequester the carbon. And so if you're already farming degraded land, there's not much nitrogen in it, where are you going to get it from? Well, you could plant legumes and you could sort of get other things in, but there's other ways to do it. So it's one of these issues where it starts to become not so black and white in terms of what the practices are. To me, though, what is in black and white is the direction we need the practices to go. So what we tend to do is we buy a lot of food from farmers markets in and around Seattle. There's a lot of access to places where we've got to know the farm, we know their practices, we like what they're doing, we buy their produce. And to the degree that we can, we eat organic, because on average that's going to be better. But I think that there is sort of an information flow. There need to be mechanisms developed so that when you actually go to a grocery store and you're buying something, how do you know how it was raised, how it was farmed? And I think that the labels that we have today of simply like organic versus GMO aren't really good enough to really understand the nuances behind what may be actually be happening. Now, you may not want to support GMO crops for many very solid reasons, and you may really want to support organic agriculture, and that's great. But those labels don't tell the whole story in terms of what it's doing to the land and the soil over the long run. And therein, I think there's a bit of a problem. Like no-till agriculture, for example, can be rebuilding soil fertility using GMO crops. Well, is that good or bad? And it gets a little fuzzy if you just view it through the lens of the soil. Now, whether you want to put that stuff in your body, that may be a whole different issue. Yeah, if you look at sort of the broad scope of human history, and you look at those, it's many regions of the world that we don't think of as terribly prosperous today. Parts of the Middle East, Lebanon, the so-called promised land of biblical antiquity. Those are areas where we know that the soil used to be much better than it is today. The problem of long-term soil loss is one that gets inherited by future generations. It's hard to reverse once it has run its sort of full course of degradation. And so if we think about sort of the intergenerational equity and trying to sustain the wealth of future societies, the best thing we can do really is to basically to not completely change the climate, but over a bit longer term, to take better care of the soil so that people inherit a world where they're actually able to routinely grow the food that they're going to need when it comes their time to inherit the world.